9.3, we're going to talk about hyperbolas. So a hyperbola is a set of all points x and y in a plane, the difference whose distance from two distinct points, the foci, is a positive constant. So hyperbolas are kind of similar to ellipses, kind of similar to parabolas. It's like two parabolas. We have foci that are in the hyperbolas. So if you think about our hyperbola as two parabolas, just like our parabola had to be a bowl with a focus in the middle, same thing with hyperbolas. It's just two of them. So we have a line segment connecting the vertices, which is called the transverse axis. So this is going to be important. And the midpoint of the transverse axis is the center of the hyperbola. So in our picture here, we have two vertices. In between those, right in the middle, is our center. And then we also have foci. All of our important information for our parabola all falls on the transverse axis. So this purple line is our transverse axis. So we can have a vertical transverse axis or a horizontal one, depending on which way our hyperbolas open. So here we have the standard form of a hyperbola. Some important things to make note of, just like we did yesterday. Our value A is going to be the distance from the center to the vertex. So A is the distance from the center to the vertex. We also have a value B. So if you notice, we have two covertices, which are not on our hyperbola. They serve little purpose, but they are kind of important. So B is the distance from the center to the covertices, or covertex. And then we have C, which, just like yesterday, it's the distance from the center to the foci. So notice in our first graph that our center, our vertices, and our foci all fall on the horizontal transverse axis. In the second one, our foci, the vertices, and the center all fall on the vertical transverse axis. So these are two standard forms for our hyperbolas, depending on what type of transverse axis that we have. If it's a horizontal one, the x comes first. If it is a vertical transverse axis, then the y comes first. And the order matters here because the difference between our hyperbola equation and the ellipse that we had yesterday is these have a minus in the middle. They have a minus in the middle, and A always comes first. So those are kind of going to be our two differences. On the next slide, again, we have our two standard forms for hyperbolas. So the first one is when our transverse axis is horizontal. The second one is vertical. And then another difference between these and what we did yesterday with ellipses are our little formula to find C is plus in the middle. So it's C squared is equal to A squared plus B squared. So this is different than ellipse. So let's do some examples. We're going to find the standard form of the equation of the hyperbola with foci -1, 2, and 5, 2, and vertices 0, 2, and 4, 2. So let's graph what we've been given. So a point at -1, 2, 5, 2. Those are our foci. And then vertices at 0, 2, and 4, 2. Do we have a horizontal transverse axis here or vertical? Horizontal. Remember, all of our important information is on that transverse axis. So they're all on that horizontal line. So for a horizontal transverse axis, what comes first in my standard form equation? The x or the y? X. So it'll be x minus h squared over a squared minus y minus k squared over b squared. It's equal to 1. Just like our ellipse, it's equal to 1. So we want to find our center, our h and k, and we want to find a and b. So let's start with the center. Just by looking at it, can we see what our center is? What would our center point be? 2, 2, awesome. It's going to be right in between our vertices. So if you wanted to count, our vertices are 1, 2, 3, 4 spaces away from each other. So the middle of those two vertices would be 2 spaces away. So our center would be 2, 2. So we can plug those into our h and k. So we know that we found almost everything we're looking for. Now we need to know what our A, B, and C are. So A is the distance from what to what? From the center to the vertex. So from the center to my vertex, what is that distance? 2. So A is 2. So in my equation, I would plug in 2 into A. What's 2 squared? 4. B is the distance from the center to the co-vertices. Do I have the co-vertices? Nope. C is the distance from the center to the foci. Do I have the foci? Yeah. What's the distance from the center to the foci? 3. So C would be 3. So once we have A and C, we can plug those into our formula to find B. So our formula is C squared is equal to A squared plus B squared. So 9 is equal to 4 plus B squared. We're solving for B, so subtract 4 on both sides. 5 is equal to B squared. So what is just B? Square root 5. But B squared is what goes into our equation here. What is B squared? 5. Perfect. So this would be the standard form of our hyperbola. So next we have asymptotes. We're actually going to save the asymptotes for tomorrow, so I'll talk about it more tomorrow. Same with the equations of the asymptotes, so we'll come back to this tomorrow. So let's look at example 2. We're going to sketch the hyperbola whose equation is this. Is this in standard form? No. Well, in our standard form equation, what does it have to be equal to? 1. So how can I make this equal to 1? Divide everything by 16. So can I simplify 4 over 16? What does it simplify to? 4 where? On the bottom. So x squared over 4 minus y squared over 16 is equal to 1. Now is it in standard form? Yes. So let's start by identifying our center. What would our center be here? 0, 0, perfect. We're not adding anything to x or y, so our center is just 0, 0. So I'm going to go ahead and graph this. Start with our center at 0, 0. Right, next, let's find our A, B, and C. Which one would be our A squared, 4 or 16? Careful here, because for hyperbolas, it's always the first one is A squared. So it's different with ellipse. Ellipse, yesterday, A was always bigger than B. But here, for hyperbolas, it's always the first one. So if A squared is 4, what is A? 2. What does A tell us? The distance from the center to the vertex. Am I going to go horizontal to, or do I go vertical to? What type of hyperbola do I have? Is the transverse horizontal or vertical? How did you know it's horizontal? Because the x is first, so we know our transverse is horizontal. So that means our vertices and foci are going to be horizontal. So I'm going to go 2 to the right and 2 to the left. That means 16 is b squared, so what is just b? 4. What does b tell us? From the center to the co-vertices. So I'm going to go up 4 and down 4. And then how can I find c? C squared is equal to a squared plus b squared. So c squared is equal to 4 plus 16. C squared would be 20. So c is square root 20. What does square root 20 simplify to? So let's see, 20 breaks down into 4 and 5. 4 breaks down into 2 and 2. Circle the 2's, so it'd be 2 square root 5. And square root 20 would be about what? About how much if I was to just graph it? Square root 20 is in between square root 16 and square root 25. So it'd be about how much? We can just say 4.5-ish, in between 4 and 5. Be a little bit more than 4, a little bit less than 5. Is my foci, so remember, C tells us the distance from the center to the foci. Is my foci going to be horizontal or vertical? Horizontal, because they fall on our transverse axis, which is horizontal. So I'm going to go from the center to the right 4.5-ish. 3, 4, 5. So put a point there. 1, 2, 3, 4, 5. Put a point there. Right, so those are all of my important points. Before I draw my hyperbolas, I want to draw my asymptotes. So to come up with the asymptotes, our vertices and our co-vertices make a box. So I draw a box that connects my vertices with the covertices. So it'd be a little box here. It's kind of like an imaginary box. Now in the corners of those boxes, diagonally, are my asymptotes. So tomorrow we'll talk about our formula to how to come up with the equation of the asymptotes, but right now we just need to know how to draw them. So those would be our asymptotes. Now our hyperbolas, when we draw those, they go through the vertex, but just hug the asymptotes. They get super close to the asymptotes, but don't cross. So they cross at the vertices, get really, really close to the asymptotes, but don't cross. Any questions here? Good with this one? Right, let's look at the next. We have to put the equation in standard form, find the asymptotes, then sketch the hyperbola. So first thing we want to do is put it in standard form. How do you think I could put this in standard form? I got to combine the x's and the y's. So I have 4x squared plus 8x. I'm going to leave a space because what do I have to do? Complete the square. Minus 3y squared. I don't have another y to go with it. So I'm not going to have to complete the square there, which is nice. And then what do I do with the 16? Move it to the other side. So I'm going to subtract 16 to move that to the other side. So I only have to complete the square with my x's. What do we need to do first to complete the square with the x's? We need to know our formula, which is b over 2 squared, but I can't just plug in 8 for my b. Why not? I have to take out that 4 first. Because the x squared has a constant in front of it, we need to take that out. So I'm going to take the 4 to the outside, so I'm dividing both the 4x squared and the 8x by 4. So I have 4 times x squared plus 2x. We're going to leave a space to complete the square there. Minus 3y squared is equal to negative 16. Now what's my b? 2. So I have 2 over 2 squared. Because it's b over 2 squared. So that'd be 1 squared. And what's 1 squared? 1. So I'm adding 1, but I'm not just adding 1. What do I have to do to that 1? Multiply it by 4. So I'm technically adding 4 here. So if I'm adding 4 on the left side, what else do I have to do? Add it to the right side too. So now in my parentheses squared, what's going to go inside? X plus 1. Perfect. And then what goes on the outside? The 4. So I have 4x plus 1 squared minus 3y squared is equal to, I've got to add these two together, so negative 12. Okay, what do I do next? Do what? Divide everything by negative 12. So simplify if you can. That would make our first fraction have what in the denominator? Negative 3. Then it changes to a positive y squared over what? 4. That's equal to 1. Is this in standard form? Why not? It's not. Why not? The -3. What do I need to do to make it in standard form? What does our hyperbola equation have to have in the middle? A minus. Right now it has a plus. We just need to flip the 2 here, the 2x and the y. So I have y squared over 4 minus x plus 1 squared over 3. Because this is negative, it's got to come second, just so we have that minus in the middle. So the -1 will always come second. The positive 1 comes first. So now that y squared comes first, do I have a horizontal transverse axis or vertical? A vertical transverse axis. So my parabolas are going to look like this, or my hyperbola. And then let's figure out all of our important information. So let's start with the center. What would my center be? -1, 0. Careful, because even though the order flipped, the h always goes with the x. So it'd be -1 because we changed the sign, and then y doesn't have anything added to it. So -1, 0. So let's graph that. I'm going to go to the left to -1 and stay at 0. What do you think I should do next? Awesome. Let's find A, B, and C. How do we find A? A squared is always first. So A squared is 4. What would just A be? 2. A tells us the distance from the center to the vertices. Am I going to go up and down for my vertices or left and right? Up and down, because our transverse axis is vertical. So we go up 2 from the center and down 2. All right, next let's find our B. So B squared would be 3. So just B would be square root 3. Square root 3 is about what? 1 point something. We'll say 1.5. It's going to be in between 1 and 2. Say 1.5-ish. So our co-vertices go left and right since our vertices went up and down. So I'm going to go from the center to the left about 1.5-ish. And from the center to the right, about 1.5-ish. No, it's not from the origin, it's from the center of our hyperbola, from that purple dot. How do we find C? C squared is equal to A squared plus B squared. So C squared would be 4 plus 3. C squared is 7, so C would be square root 7. Which is about what? Two point something. We can say 2.5-ish. It'll be in between 2 and 3. Because it's greater than square root 4, but less than square root 9. So for my foci, because C tells us the foci, it'll be from the center. Do I go left and right for my foci or up and down? Up and down, because that's where our transverse axis is. Our transverse axis is the vertical line. So I'm going to go up 2.5-ish from the center and down 2.5-ish from the center. What do I do next? Draw the box so I can draw the asymptote. So I'm going to connect my vertices and my co-vertices with a box. Little imaginary box there. And then the diagonals of my box and the center make my asymptotes. Then once we draw the asymptotes, we can draw our hyperbola. So the hyperbola kind of hugs the asymptotes and it goes through the vertex. So just make sure it connects the vertex, and the foci are always going to be inside that hyperbola. The hyperbola is going to be like a bowl that holds the foci, the focus in there. So that would be our graph.